Hello, my dear students. Today we'll discuss about the gravitation. So, what is gravitation? Which animal's name is this? So, to find the answer of these questions, I have some question which will help you to better understand about gravitation. First question is that, have you ever wondered why does anything thrown up falls down? And second question is that, why is going uphill lot more tiring than going downhill? Answer of these questions is that there is some force acting on them called as gravitational force. So what is the nature of gravitational force? Gravitation, first nature is that the gravitation is weakest in nature, and second is that it is negligible for tiny particles. So thus it does not play any roles, or you can say no role in the case of the attraction of tiny particles like molecules, atoms, or nuclei. So what is the Newtonian gravitation? As we all know that Sir Isaac Newton did not discover the gravitation, but he was the first person to understand broader significance about the gravitation. So let's see the rules which is given by Newton's universal law of gravitation. What is the rule? According to Newton's, every particles of matter in the universe attract every other particles with force. That force is directly proportional to the product of the masses and inversely proportional to the square of distance between these two masses. Which two masses? This m1 and this m2. So let's see. The force F1, which is acting on M1, which is acting by what you can say, which is acting by M1 and on M2, and the force F2, which is acting by M2 on M1. So this force is acting along the center of these two masses, along the line joining of the center of these two masses. It does not acting like this or this, right? It does not acting like this. It always acting the line joining of the center of these two masses. Let's say the force, this force is directly proportional to the m1 and m2. Let's say this equation is first, and second, if this f is directly proportional to the square of the distance between them. Let's say this equation is 2. So by combining these two equations, you will get f is directly proportional m1 m2 divided by r square. If you remove this proportionality, you will get proportionality constant and equal sign. That proportionality constant is known as universal gravitational constant, which has a value of very small 6.673 into 10 to the power minus 11 Newton meter square per kg square. I'll get the unit of capital G. So from this equation, G will be what? G is equal to F into R square divided by M1 into m2, right? m1 into m2. So from this you will find that Newton, the unit of SI unit of force is Newton. R is nothing but what? Separation between these two masses, means distance of these two masses from the center. So what is the SI unit of distance? Is meter only. So Newton and meter square. This mass, SI unit of mass is kg, and this mass is also in kg. So kg into kg is kg square. So SI unit of capital G is Newton meter square per kg square. Right. Here the force F1 which is acting by M1 is equal to the force F2 which is acting by M2. F2 is acting upon F1 is acting upon M2. F2 is acting upon M1. So according to Newton's third law, these two forces are equal. But what about the direction? So you can see here the direction is opposite. So what is Newton's third law? Newton's third law was for every action there is an equal and opposite reaction. So F1 is equal and opposite of F2, right? So let's talk about the universal gravitational constant. Proportionality constant G is called the universal gravitational constant, and the value in the SI system of unit is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Here, what is the application of universal gravitational constant? Or you can say what is the application of gravitational force? So, it can be used to understand the motion of planets and moons. It determines the surface gravity of planets and the orbital motion of artificial satellites, right, around the Earth. Thank you.